Hey kids, it's JJ again. I had a request. I showed some basic tools of the trade yesterday, a little video for a buddy, and I said something about a meter test, and somebody said, hey, I'd like to see a basic meter test. And I've got a little bit of free time, I think, before Mama gets home, so I'm going to go ahead and walk you through some stuff. If you want to go a little bit more in depth, obviously there's tons of stuff on the internet that deals with flukes or deals with meters. Shoot over to RC Model Reviews. I'll put a link right here with Bruce Simpson. He goes through a lot of electrical theory, which is great. Like I said, in my line of work, I do tons of everything from 483 phase down to 5.3 volt DC, whatever. But what I want to do is I want to focus just on quadcopter things, basics that you need to know for quads. Okay. First off, let's go over the meter a little bit. Now, this is a fluke. I don't think I have a cheaper meter, but they're pretty much the same. Let's just go over the basics that you'll need here. There's off, obviously. These are your probes. If at all possible, get probes that have a tight tip, not blunt, okay? Because when you need to try to get into these Molex connectors and stuff, it's much better to have good tips, good probes. The very first one on mine, this symbol right here is AC or Hertz, okay? We're not going to get into Hertz and frequencies and all that dielectric theory, but volts for AC. So if you're going to check your house, I'll go ahead and plug these probes into a outlet. Your house is AC, obviously. There you go, 120. Now, what else is AC is your quadcopter, believe it or not. The ESCs on your quad are actually AC DC inverters, okay? So you got DC coming in here from your battery, flight controller, power distribution board, all that stuff. And then it gets converted into AC three-phase, believe it or not. And those of you that are in industry like I am with CNC machines, robotics, and big old mills and things like that, anything in a factory is pretty much 483 phase. This is AC three-phase. So if you want to check to see if your motors are putting out power, and I'm not going to do it because I don't think I got anything with the props off. It'll take too long. But what you can literally do is fire up your quad without the props and arm it, and then if you're getting no rotation here, put it on AC, and then see if you have your three phases coming through a voltage. And we can do a video on that later on someday. But if that's dead to the world, you probably lost some guts in here. So that is the only thing on your quad that's AC that you'll ever use AC for, or alternating current, boom boom, which looks like a sine wave. All right. The next meter setting is DC. You're going to use this all the time. Direct current. DC is like your car battery, your LiPo batteries, everything on your quads is DC. So, for instance, let's see. I'm going to do something dangerous. I'm going to plug this thing in with props. That's bad. Do as I say, not as I do. Okay, so obviously red is positive, black is negative in DC world. So I'm just going to put some probes on my input power of your ESC. See, I had to push really hard, 16 volts. I got a 4S on here. The reason I had to push really hard to get a meter reading on that is because these are conformal coded. My waterproofing method that I use on everything, which I harp on all the time. So, if you've conformal coated your quad, dig your probes in a little bit to break through that film, okay? DC current, if you're going to be testing your LiPo batteries, you can test them. This one's a goggle battery, so it's a bad example. Let's take this guy. Black to black, red to red. It really does not matter, though. If you have it on backwards, you're going to get a negative symbol. Hang on, I got something on my phone. You got a negative symbol on your meter. So, for instance, we're going to test this battery. 16.25. Now, if I flip my probes, negative 16.25, because it's direct current. In the olden days, we used to reverse motors by flipping the current. Let me grab a meter real quick. All right, What did I say that was? 16.5. These things here are great. I keep one of these in my backpack all the time. Digital lipo capacity checker. So I can take my balance plug it into here. What do I got? 16.2. Let's plug in our probe again to DC current. All batteries are DC, at least in this world. 16.25. So we're off a little bit. Which one of these do you think is off? I guarantee it's that. $300 meter or that, you know. But these are good enough for the girls we date. This is fine. I keep this in my my pack at all times. It'll do life batteries, lithium ions, whatever. And you can go per cell. I can hit the cell button. 4 volts. That's 1S, or the first cell. I don't know if you can see that. 2S, which is the second cell. And 3S, which is the third cell. And 4S, which is the fourth cell. So if you're getting a funky battery, for instance, you pop in your battery, you start flying, it's flying like a rape date, and then all of a sudden, bam, you just get a huge voltage drop. Bring that bird in, plug it into one of these guys, and you can do the same thing with a meter, and test each cell. If you have one cell that's sagging way below the others, but yet it charged up normal, nah, you got a problem. Okay, so we can do the same thing with the meter. I'm going to try and do this in shot. We'll see what happens. You got black, red, 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 red. For those of you that don't have color coded on here, whenever you look at a balance connector, the far right, you know, when you got these ribs up, is always your ground. Because I do have balance connectors that aren't black and red. So we're going to put our ground on the ground, obviously. See if I can do this without frying myself. And then first cell, 4 volts. Second cell, 8 volts. Third cell, 12 volts. There you go. Because LiPo batteries are wired in series. Okay, that's a whole nother devil. And there's zillions of videos out there. I can touch on it if you want. I actually have a battery building video that I did a while back. Anyway, so that's a good way to check your DC. Let me grab a flight controller. All right. And this goes for power distribution boards. This goes for anything that, see if we got something that's marked better. Not really. All right. Anyway, if there's ever any doubt, you can, like, let's just make some assumptions. And actually, this assumption's probably right. You've got your voltage coming in here, which is going to be your 5-volt positive, and then these are your grounds. You can simply test these. And like I said, it doesn't matter if your probes are backwards, just get a negative symbol over here, but it's good advice. Let me see if I can find the power distribution board. Hang on. Here's one. Now, this one looks like a bag of ass, so that's good. I'm going to plug a 3S into it, just in case this thing's south of cheese. So we're going to plug a 3S in. Look at that. Got lights. Wow. Okay, it's in the junk drawer. I'm surprised. And we're going to test. Now, let's test our power distribution board. These are your power outputs for your ESCs. Notice you got positive, negative, negative, positive, blah, 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 blah. So you can always test. Take a negative probe, positive probe. There you go. We got 5 volts coming out. 5 volts coming out. Now I have my probes backwards and you saw the negative, that's fine. And then we can test our, if you look on this board right, ground in 3 volts, ground in 12 volts. And you know, you can test all that too, obviously. Stick your ground there and your hot there and see if you get 3 volts. Let's see if that happens. This one may have a jumper on it. 3 volts, 3.8. Yeah, okay, that's pretty high. But anyway, you get the gist. Now, one thing, let's move on. You get the idea of DC. You can. This isn't about testing quadcopters. This is really just a quickie tutorial for your meter. Millivolts, you can test it. You know, if you want to really get down to the scurvy there. Ohms. All right. Ohms is resistance, obviously. There's not a whole lot you do. I mean, if you're going to do board level stuff with resistance and testing resistors and things like that, testing motor leads, things like that, open and close, yeah, you don't have a heck of a lot of that in the quad thing. Here and there, you do resistance. Trying to think if I'm trying to do this fast, but next over, and this is the one you will use a lot, is your diode check and or your continuity check. Anything that's in yellow, I believe that's yellow, that's, you got to hit this to change the mode. See there, it goes into diode mode. There, it's back into continuity. This is continuity, kids. Direct short to ground, or direct short, okay? So all of your grounds in the quadcopter world, unless it's video sometimes, are all the same, or what they call a common ground. So if I put a ground probe here, or a probe here, and a probe on this ground, oh, this one's isolated. There it is. Conformal coding, okay? Notice these grounds are the same, but these positives are probably the same too. Yep, they are. This is just a breakout board, okay? These are not individual. But you saw in another video that I did, always do a prostate check. Prostate check is after you get done changing stuff. Like I just put my Cobras, where the hell did that quad go? There it is. I just put those new Cobras on my D215, okay? I did have a soldering error, believe it or not. It was on motor number 4. And for those of you that are going to poo-poo me, I did zip strip down my wires. This one was getting sketchy, like it had lost a phase. It was going click, 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 click. It would not spin. I thought, well, shit, I hope I don't have a bad motor. So my first instinct was I didn't even meter it out. I just literally unsoldered it and soldered it back in. I had a cold solder joint. Thing spins fine, as you see in the video. But even that, even when you do a slight little change, all I did was take that off, put that back on. But those are some pretty tight solder joints in there. Give it a prostate check. Put it on continuity. Stick the probes in its ass or the thumb up the butt for a prostate check. And you should hear it beep one time and stop. Like that. If it goes continuous, I'm going to short out here. You have a problem. You have shorted something to ground or you have cross-phased somewhere. Always do a prostate check. This one, since I just had a battery on it, should also do the beep. Man, I need to clean that pig. That shit's dirty. See? Beep. Done. I have many times, I like to have a good old drink at night. I do a lot of my work during the day or when I'm drinking, and I have fucked up and cross-phased stuff, and that prostate check has saved my ass on a lot of stuff. So always put it on continuity and check your bird. So that's, you can literally, we're still on continuity, go ground from this ESC. I'm going to grind it in. Ground to this ESC. Aha, we have connection. We have connection. We have connection. All my grounds. Let's go to the positives. Yep. And you just saw on that power distribution board, this is just a breakout board, okay? So basically all these positive and negatives come from the same source. So from a continuity or direct short standpoint, positives should all be shorted together and negatives should all be sorted together, okay? Or what we call in my industry jumped in, jumped out, whatever you want to call it. So extremely useful. You'll use that a lot. For diode check, you don't see a lot of diode checking in quads. You can, but for a diode check, diodes are valves, electrical valves. They only let power go through one direction. They will not go the other direction. So, for instance, on my radio, my transmitter, my heavily modified transmitter, you'll see where it says, I don't know if you can see it, anti-reverse design. Yeah, that's a marketing plug for, we put a diode in there. That's all that is. Diodes are used for that. They're used for a lot of things. LEDs are technically diodes, light emitting diodes. But basically what that does is if you hook that battery in backwards, it will not let the power flow through. So in theory, I don't have a diode handy, but if you put this on diode check, right now it's on continuity, hit your yellow button, or mode change button, it goes to diode. I should be able to go positive on the ring side of the diode, negative on the other side of the diode, and it should flow just fine. You should get continuity. If I flip my probes around, it shouldn't flow at all and you should get no direct short. But again, we don't do a whole lot of diode testing in quad world. DC milliamp, DC millivolt. This one has temperature up here. That only works if you have a temperature probe. And amperage. You do use a lot of this, but you do have to switch your probes out for amps. And I'm not going to get into that. You only usually use amperage on a meter in this world of quads if you're tuning in. I mean, if you're bench testing a motor the right way, which you never see me do, I just put it on a quad and see how the shit flies. I don't put props on it, put prop stands and do thrust measurements and all that shit. I just look for motors that don't kill batteries and that fly really nice. I'm sorry, I don't get that geeky with it. And there's plenty of guys out there that do. Bardwell, I think, does a lot of that. Well, I don't even think he does a whole lot. I call him Jelly Bean now because it's just, I think it's funny. Who's that other cat? Bench Test Reviews or something like that. He does amazing work with motors. Go to him and watch his motor stuff. Come to me if you want to say, hey, dude, check these out. These are badass. That's about it for me. You've seen my motor reviews. But yeah, so if you're going to calibrate your amp meter, current meter in your flight controller, you use that, and things of that nature, which I don't use a current meter on my flight controllers. I have flight controllers that have them that tell me how much milliamp drawn per flight. One, I'm too lazy to calibrate it. Number two, I don't care. All I really care about is my voltage and where I'm at on a time wise. Voltage versus time is all I care about. If I see I'm at 10.5 volts and my fly time's at 320 or whatever, then I know I got to bring my shit in or it's going to blow up. So that's really good too. Let's see, what else is there? Hold, you probably won't use that. That's just to light it up. And your range, if you're going DC really high voltage or low voltage, you can do your range, manual range. Usually with most automatic meters, you don't even have to mess with that. Now, I wish I had I don't have a cheapo analog. You'll see a lot of meters that guys buy and they work just fine for this hobby, where they've got a zillion dials, things on them. Like mine only has like 6, but it's all computerized. Those are, you have to put it on the voltage. So for instance, I wish I had a picture to show you. If you've got a DC section, DC is symbolized by your straight lines, AC is symbolized by your wavy lines. If you've got a section that has DC lines, it's like from here to here, and it goes 10, 20, 30, 40, 60, or, it's got a breakout from 10 volts to 200 volts, and then it's got an AC from 10 volts to 200 volts or whatever it is. I haven't used one of those meters in forever, so I don't know. Basically what you want to do, you have to know your voltage range, because if you put that thing on 200 volt DC and you go to check your battery, you're going to get a lot of decimal places and it's going to show you like 0.2 of a volt. So you want to put it on, so let's say your meter goes from 10 and then the next one is 50 and the next one's 100. Put it all the way down on 10, between 10 and 50, because you know with that, this voltage is not going to be below 0 and it's not going to be above 50. So those are the cheaper meters, which are fine to use. How to use them is a little bit different. I wish I had one to show you guys. All I've got is about 5 flukes, so I don't have any of those style. Very, very useful to have. Let's see, am I missing anything? Really, that's about it. For quadcopter stuff, guys, you don't have to get down to board level oscilloscopes and doing dual trace runs on circuit boards. I mean, you can, but like I said in my video last night, my time's worth more than that. I'd rather just spend another 20 bucks, buy a new board or whatever. But that's just a real quick rundown of your meter. And if you want me to go more in depth with it, I can. Again, go over to Bruce Simpson. RC Model Reviews, brilliant man. I love him dearly. He's a cool guy. He has tons of theory videos on electricity and DC current, AC and 5.8 megahertz and all that. The guy's brilliant. I love him dearly, and I don't know the guy, but I watch him religiously. So if you want to get the really in-depth stuff, there's no sense in me doing it. Go over there and watch him do that, and you'll learn a lot from that guy. He's absolutely brilliant. So anyway, this was a lot longer than I thought. I hope this helps you out, and I'll talk to you later. Take care, kids. Bye.